Alright, for this video here, we're going to start getting into the different types of furnaces, their constructions, and what makes up their efficiencies. So, your furnace types and construction, really, what determines the design of a furnace is really what it's going to be used for, where it's going to be, and what type of medium that we're going to be heating. All right. So for natural gas, obviously, we're going to have either natural gas, propane, butane, ethane. All right. But we're also going to have different transfer mediums that we're going to be trying to heat. Now that could be air, that could be water, if it's a boiler, steam. All right, so we have different criteria that we need to meet in order to achieve what we're trying to do. But we have different types of furnace constructions that are out there. All right, we usually come into several different ones. We have our upflow, our downflow, and our horizontal. Your upflow furnace is the most common type due to its building construction. It takes air and forces it up through the bottom of the furnace. An inducer blower motor increases that system's efficiency, and it forces air through the heat exchanger and then into the ductwork. So here we are. We have our heat exchanger up here. We have our inducer motor, and we have our blower. So as we are heating the air through our burners, this heat exchanger is going to heat up, get all nice and hot. Our blower is going to turn on, and it's going to force the air up across that heat exchanger and then out into our supply duct into our space. The inducer motor helps with the combustion process. It helps pull the flame into the heat exchanger, and it also helps pull the products of combustion out of the heat exchanger and out our flue pipe. Downflow furnaces are also referred to as what we call counterflow type furnaces. These forces the return air from the top of the furnace downward through the heat exchanger. Your horizontal furnaces requires the air to flow horizontally through the heat exchanger. Return air is pulled through the end opposite of the heat exchanger. All furnace types require installation of a cold air return to supply the furnace with air to be reheated or recooled. Most furnaces are of steel construction. The blower compartment is lined with insulation to reduce heat loss or heat gain and reduce noise. A section is provided for the installation of an air filter. A safety interlock switch is often provided inside the blower access door, and when the door panel is opened or removed, the switch de-energizes the electrical power to all your components. That is known as your door switch. Newer furnaces have very high efficiency ratings. These furnaces use less fuel and produce more heat. The measurement of efficiency for furnaces is known as the Annual Fuel Utilization Efficiency Rating, or better known as AFUE. It compares the yearly and annual energy output to the annual energy input. The higher the AFUE rating, the more efficient and cost-effective the furnace is. The federal government's minimum efficiency standard is 78% AFUE. Higher efficiency furnaces today have ratings above 84%. So if we look at this chart here, it kind of gives us a little bit of an idea of the approximate yearly operating costs for various furnace efficiencies. So if we look and we say we have a furnace that is in a home and it's only running at a 70% efficient, And they're saying that it takes them probably about, we'll say, $500 a year to run that furnace. If we are able to upgrade that furnace to, say, a 92% efficient furnace, it's going to save them almost $100 a year in operating costs, simply due to the fact is that the furnace is running at a much higher efficiency. Okay, high efficiency furnaces may contain improvements in the flue pipe routing. It may have a high transfer heat exchanger in there. They may come with a secondary heat exchanger that extracts as much heat as possible from the system. The temperature at which flue gas is emitted to the atmosphere is then reduced, and that reduction in flue gas temperature results in condensation of water vapor. So here we have a high efficiency gas furnace. A characteristic of a high efficiency gas furnace is that it will have PVC for its flue pipes, not standard metal. Reason why we have PVC pipes on our high efficiency standard furnaces is because the flue gas temperature is 100 degrees, approximately 100 degrees. Usually your high efficiency furnaces will also have a primary and secondary heat exchanger in them, which is how we are able to reduce the flue gas temperature going out our chimney. Your mid-efficiency furnaces have an AFUE rating of approximately 79 to 83%. They use high heat transfer heat exchangers with induced draft motors. They will usually have a flue gas outlet of only 3 inches due to the heat exchanger design and decrease in combustion products. They may use Class B chimney or approved flex chimney liners, so you might have to check with your local municipality to see whether or not you have to install a chimney liner, or you can or cannot use Class B chimney pipe for these type. It may be low profile and installed horizontally or vertically. All furnace installations must conform to all recommendations of the manufacturer and your local codes. So in other words, we just can't do whatever the heck we want to and put them wherever the heck we want to. Mid-efficiency furnaces will vary from high-efficiency furnaces due to the lack of that secondary heat exchanger. The chimney with exhaust gases also varies. Hot flue gases are sent directly through the chimney, and much of the heat energy is lost. And your mid-efficiency furnaces are going to have 3 sections to them. You're going to have your burner section, you're going to have your heat exchanger section, and you're going to have your venting system section. The operation of a mid-efficiency furnace is relatively simple. You have your thermostat that's going to call for heat. The gas valve is then going to open. The gas flows to the burner, where you will have a spark igniter, which is going to ignite the gas. The flame then warms up the heat exchanger. That in turn warms up the air. Your hot gases from the combustion collect at the top of the heat exchanger and then is routed to the vent. High-efficiency furnaces, better known as your condensing furnaces, are most popular among furnaces on the market. Why? Because they have a high AFUE rating of anywhere between 84 to 95%. Most of the components are going to have your flue piping, your heat exchanger, and your secondary heat exchanger. These types of furnaces are very, very common today in the market because nowadays everything is energy efficiency and Energy Star ratings. So you need to have a high AFUE rating in order to achieve that. The operation of your high efficiency gas furnace or condensing gas furnace is, you may see, on some cases you will see 2 penetrations at the top. One is for your actual exhaust, for your flue gases. Another one will be for your fresh air intake. So with these types of furnaces, the outside air entering through the PVC pipe runs through the wall or roof. A traditional chimney is not necessarily needed for these types of furnaces. Your exhaust is through PVC pipe running through the wall or roof. And the operation of this is the gas flame heats the primary heat exchanger. The combustion blower draws your hot combustion gases through the primary heat exchanger. The hot gases produces the combustion are drawn down by the combustion blower motor into the secondary heat exchanger. Here, latent heat is now exchanged, lowering your flue stack temperature and condensing water vapor. The indoor blower forces circulated room air across your primary and secondary heat exchanger. Air picks up that latent heat of vaporization from the flue gases. The hot air created by the secondary heat exchanger is circulated through the furnace duct system. Your exhaust gases are low in temperature and vented outdoors through the PVC pipe. Your primary air for combustion is conducted from the outdoors through a PVC pipe. You may also run into an integrated mechanical system or space and hot water heating system. Your high efficiency warm heating system that provides both space and water heating. The rated according to your combined annual efficiency rating, CAE. The reason why we have a different rating when it comes to a unit that does both your space and hot water rating is simply due to the fact that the unit is a combination of both. Such a system is the complete heat system, and they have a CAE rating of about 90%. Systems produce 3 or 4 times more hot water than conventional water heaters. They can be vented vertically or horizontally with a 2-inch PVC pipe. Outdoor air is used for combustion. The system has 2 modules in them. It has a heat module, which acts as storage, and it has an air handling module, which provides comfort conditioning for the home. The operation of these is pretty simple. On the call for heat, the pump in the air handling module draws hot water from the heat module and circulates it. The heat from the water is then transferred through the use of the heat exchanger and the blowers. Water returns to the heat module where it is now reheated, and your hot water for domestic use comes directly from the heat module. You will also run into 2-stage furnaces. These features 2 levels of heat, adjusts the output based on the demand inside the house. A majority of operation is in the first stage, or what we would consider low heat. The low heat stage requires less energy consumption, offers greater efficiency, and provides greater cost effectiveness. On colder days, the furnace moves to a high heat stage, or what we call second stage. The motor adjusts automatically to meet the changing needs. The 2-stage heating reduces temperature swings, providing consistent and comfortable temperatures. A variable speed indoor blower creates a more consistent airflow, allowing the air filter to trap more impurities, therefore improving your indoor air quality. Here is an example of a 2-stage modulating furnace. Okay, these types of furnaces provide a rating anywhere between 40% and 100% of its total capacity. A solid-state integrated furnace control initiates and manages the sequence of operation. The unit automatically chooses the most efficient blower motor. Most of your 2-stage furnaces today will have a circuit board on there that will modulate your blower and your gas valve. Depending on the amount of heat needed in the space, your gas valve will either open more or close, and your blower motor will either ramp up in RPMs or slow down. You will also run into unit heaters. These are going to be used in a lot of your commercial buildings and factories to heat certain rooms and spaces. They may operate by natural gas or propane. It will have a polished reflector which radiates the infrared energy that is converted into heat as it reaches the occupants and workspaces. The surrounding air becomes warm by conduction and convection. Unit heaters are available for downward warm airflow. These provide high velocity airflow, anywhere about 2,500 feet per minute. Against large door openings, they are usually mounted 3 feet above or 4 feet away from the opening, and the unit is operated by a door switch or thermostat connected in parallel. Venting of your furnaces, chimneys, or exhausts, you have several different areas that you need to pay attention to when it comes to venting a furnace. For mostly, as you see here, you have your furnace capacity. We need to know the type of piping. We need to know the airflow, how long our chimney exhaust run is going to be. We need to know the heat load of the entire building. We need to know how many elbows that we're going to need to make that connection. We also need to make sure we follow your manufacturer's recommendations and also all of your local code requirements. The flow of chimney gases out of the flue and chimney affects the heating efficiency. Fuel losses of about 4 to 15% is actually possible on some of our furnaces. The chimney or vent pipe should extend at least 2 feet above the highest part of the roof to prevent back pressure in the chimney or vent pipe under windy conditions. If this is not followed, you will have a backdraft condition, or you may start seeing a lot of rollouts on your furnaces. So make sure that your chimney and vent pipes extend at least 2 feet above the highest part of the roof. The combustion gas flow is affected by the pressure difference between the combustion air entering the furnace and the combustion air leaving the flue and chimney. Pressure in the building, atmospheric pressure, and the temperature of the combustion gas also affects the flow of your combustion gases. Exhaust gases are removed from a conventional furnace through the vent system consisting of a flue pipe that is joined to the chimney, which is vented to the outside. Flue pipes can reach a temperature of 500 to 600 degrees. The efficiency of the furnace is reduced by 30 to 40% because heat exhausted out of the chimney. You need to make sure that you understand and know what type of chimney you are dealing with. A Class A chimney is usually masonry. A Class B is your double wall metal type, as you see here on the left. You also will see on your high efficiency furnaces, they are going to be made of PVC. You may also be running into metal flex liners, and those are going to be inserted into the entire length of a Class A masonry chimney. Now, if you look at the image on the left, there you have an exhaust vent and you have a combustion air intake. Your exhaust vent is going to be sticking straight up out of the chimney, extending 2 feet above the peak of that roof line. Your combustion air intake will be slightly lower and it will be pitched downward, as you see on that image. That exhaust combustion air intake is sucking in fresh air into the furnace so that you can have complete combustion. Your flue pipes need to be pitched a minimum of 1/4 inch per foot back towards the furnace so that you can get rid of any sort of water vapor that is sitting inside the flue pipe. You may have to install your chimney liners. A clear and unobstructed chimney is necessary. Any tar or creosote has to be removed. Check the chimney for any cracks, loose, or missing bricks. Make repairs as necessary to provide safe internal and external conditions. Chimneys must provide at least a 1/2 inch space between the liner and your masonry inner wall. The proper liner dimension must be used to ensure good exhaust. So check for proper venting following installation and startup. High efficiency furnaces do not require a traditional chimney. Your flue gases leaving a high efficiency furnace can be anywhere between 115 and 118 degrees. Exhaust gases are vented outside through PVC pipe. Your outdoor air brought in for combustion is also through a PVC pipe. A furnace may be vented vertically or horizontally. When venting a furnace horizontally, manufacturer's procedures must be followed. Your venting pipe should follow the shortest route as possible with the fewest amount of elbows. Intake and exhaust vents exiting a sidewall must be as accurate as possible. A drain line is necessary for disposal of condensate. Furnaces must be individually vented, not combined with other appliances. A PVC connection must be leak tight, which means you are going to be priming the PVC and you are going to be cementing all of your fittings together. A bimetal damper may be installed in the flue outlet opening or as a section of flue pipe. Okay, these types of devices can be either thermally operated or require no motor or switches. A vent damper may be electrically operated and wired to open on a call for heat and close when the thermostat is satisfied. To help solve negative pressure problems created by a tightly constructed home, buildup of slight pressure in the home can create issues with combustion, so therefore you're going to have a make-up air system. And what we do is we have to provide infiltration around windows and doors, which is going to eliminate drafts. It's required by code and regulations in many states. Make-up air is used to improve furnace efficiency by providing proper air for combustion. Deliver fresh air to the furnace. Air is cleaned by filters, heated or cooled as needed, and circulated throughout the duct system.